The tools associated with developing a project schedule are essential. They provide the methodology and analysis that will become the foundation for scheduling activity work. For example, for applying the critical path method, the project team can analyze activities to determine start and finish times and apply early and late scenarios to those start and finish times. This generates a timeline for which the project's critical path is determined. The critical path is then managed as a project constraint, time, to ensure project activities identified are scheduled within the boundaries of the project's critical path. The tools used to develop a project schedule are Schedule Network Analysis. The analysis helps deliver the project schedule. The most common technique in regard to schedule network analysis is the critical path method. However, there are others that you should be aware of. There may be questions on them during your project management certification exam, such as what is analysis resource leveling and what is the critical chain method? Critical path method. The critical path method calculates the early start and finish dates as well as the late start and finish dates for all activities, from initiation to completion. Resource limitations are not incorporated into this analysis. Using early start, early finish, late start, and late finish dates enables the project manager to perform both the forward and backward pass in regard to the duration of work packages within the nodes incorporated in the network diagram. Early start, early finish, late start, and late finish simply indicate time periods for the activities scheduled. Critical path method takes into account the possibility of resource float, which provides for a degree of flexibility in scheduling project activities. The term total float on any network path reflects on the schedule flexibility by measuring the positive difference between early and late completion dates and work packages. The term free float represents the amount of time an activity can be delayed without delaying the early start date of any of its successors. Work packages with either a zero or negative total float are considered to be on the critical path of the project. In other words, if you would add up the total float for the critical path of a project, it would equate to zero. The critical path represents the longest duration of combined tasks to meet the project requirements. Critical chain method modifies the project schedule to accommodate limited resources. Here, the project schedule network diagram uses duration estimates with dependencies and constraints as inputs. The critical path is then calculated. Once a critical path is identified, resource availability is entered and the resource-limited schedule is determined. This often creates a changed critical path due to a change in schedule. Critical chain also incorporates duration buffers, which are non-work schedule activities that assist in managing uncertainty. One buffer added to the end of the critical chain is called the project buffer, which serves to protect the target finish date from slipping along the critical chain. Additional buffers, called feeding buffers, are placed at critical points in the chain of dependent tasks not on the critical chain, but that feed into the critical chain. Feeding buffers help protect the critical chain from slippage. The size of each buffer accounts for the degree of uncertainty and duration of the chain of dependable tasks. Once the buffer schedules have been determined, planned activities are incorporated with the latest possible start and finish dates. In comparison to managing float, critical chain manages remaining buffer duration against the remaining duration of task chains. Resource leveling is applicable to existing critical path methodologies. Resource leveling is a technique used to determine the best approach for addressing an unbalanced use of resources over time. It is also used to resolve conflicts that can arise from overallocations, where resources may end up being scheduled for more than one project activity at one point in time, or being double booked. Project management software applications can be used to delay scheduled tasks until the right resource becomes available. But these types of actions will impact a project's critical path. Schedule compression techniques, where additional resources are used to shorten the duration of a project's critical path, or the project's critical path is shortened by running more activities in parallel, enable resources to be applied in a manner that helps drive project activities in alignment with the project's constraints. A project manager would capitalize on resources that may be available based upon lead or lag time from non-critical path activities. By applying that resource time, lead or lag, to resource leveling needs, the project manager is working to optimize resources or respond to the impact of a change that could modify project deliverable dates. Resource leveling issues arise when subject matter experts or key resources are available on a limited basis. Unfortunately for the project managers, most tend to work multiple projects at one time. The same holds true for project-based resources, so their availability may be limited at times. Resource leveling helps address this issue and is necessary when resources are overallocated. Resource leveling can have an impact on a project's critical path. While there can be benefits to effective resource leveling, they often come at a cost to the project. Additional resources may not be budgeted, or changes incorporated into the project can create resource requirements that were not incorporated into the original project plan. In either case, the situation needs to be managed effectively with minimal impact to the project's critical path. What-if scenario uses scheduling to develop scenarios that visualize impacts to project's development activities. For example, a what-if scenario could illustrate a delay of a project due to external factors such as raw material availability or labor disputes. In each case, the project manager and team would need to create an action plan that provides transparency or proactively addresses an issue that could impact the progress of a project. A common technique aligned to what-if scenario analysis is known as the Monte Carlo analysis, as in the casino, since it is based on hedging your bets, based on odds and probability. The distribution of possible outcomes is defined for all activities and used to calculate and distribution of entire projects. Within the Monte Carlo technique, repeated random samplings and probability distributions are computed as simulations of activities. Those simulations deliver results that are then compared and analyzed to determine the alternative with the highest probability of occurrence. Leads and lags. Leads and lags can act as refinements applied during network analysis to help smooth the project schedule. Smoothing is a technique used to address conflicts within a project. Smoothing is considered a no-solution technique because nothing is actually resolved by smoothing. With smoothing, the project manager concentrates on areas of agreement to progress activities. When it comes to addressing conflicts within a project, smoothing is one technique available to the project manager. Other techniques, such as confronting, where opposing sides address concerns directly for a win-win solution, compromising, where opposing sides partially relinquish positions for a lose-lose solution, forcing, where there is a win-lose solution, withdrawal, similar to smoothing, where no solution is produced. Schedule compression permits the project manager to compress the project schedule without impacting scope. The most common technique for schedule compression is known as crashing, where cost and schedule trade-offs are reviewed to determine the greatest degree of compression at the lowest possible cost. Crashing only works for work packages where additional resources can actually shorten the task's duration. Crashing, while effective at times, is an alternative that can add risk to your project and increase the project's cost. Fast tracking permits project activities that are originally scheduled in sequence to be run in parallel. Fast tracking works well if activities can be overlapped to assure the overall project duration. Automated scheduling tools are systemic tools that serve to expedite the overall process by generating start and completion dates based upon data provided.